All right, so in this video, we're going to be going over how to find area of regular polygons. And so in other videos, we've seen how to go about finding some interior angles, also some exterior angles of a polygon, and also talked about how to find just a single interior angle as well as a single exterior angle. But for this, there's a couple things that you need to know before you start approaching finding area of a regular polygon. And so I'll start by focusing on just maybe a triangle as our first regular polygon here. And so when it comes to area, we should already know that for a triangle, so area of a triangle is always going to be base times height divided by 2. And so, actually, let me grab this really quick. And so with this triangle, it just depends on the given information. So we would want to be given a base, for example, let's just call that 3. And then maybe we say our height that we are given is 10. Just this is all refresher. So if I'm going to find the area of this, right, which is the shaded plain flat version of this, then I'm going to take 10 times 3, and then I'm going to divide that by 2. And so for this, our area is 15. And the reason why we go over the area of a triangle first is because of what I'll show you next when it comes to regular polygons. So we can use an example such as let's use a square. Cool. And I'll make that a little larger so we can look at it better. All right, so there's a couple things required for you to find area of regular polygon. The first thing you need to understand is that there's a center at every polygon, right in the middle. And what you can do with that is you can make a number of triangles on the interior, on the inside. And don't get this confused with sum of interior angles, or we were drawing out our triangles a little bit different. But remind yourself that all these corners here, these are called, plural would be the vertices. What you can do is you can take the center and you can draw triangles. So from the center to each vertices, just like this. And you can see right now that's going to make 4 triangles. So I'm going to go ahead and fully draw that out. So just connecting the center to a vertices to a vertex, center to a vertex. And so now you should notice, okay, here's 1 triangle, here's 2, here's 3, and here's 4. And what's nice about this is if you have certain information, if you're given certain information, you can actually find the area of one of these triangles first. And we know how to do that, right? Base times height divided by 2. And so it looks like in this problem, right? Let me give you some given information. So maybe we'll say the side right here is going to be worth 5, right? So that would be the base of the triangle, right? But I'm missing the height, okay? So all of these are missing a height, so I can't go on. And this is where in certain examples, you kind of need that information in order to move forward. And so what I'm going to do is I'm going to draw another point going from the center down to the middle, or the mid segment. Oh shoot, the mid segment of this side right here. So blue line, I just drew that right there, and it looks like a height, right? It looks like a height for this triangle here. This has its own special name, and that is called an apothem. So far, I've been given this base, and I've been given the apothem. And I want you to treat the apothem as if it were the height of this triangle. And so let me add some value to it. Let's say that this apothem is, let's just say it's 10. So now I have enough information to find area of this first triangle. So I can do that. I'll do that on the right over here. So that means I'm going to take the apothem, or the height of that little mini triangle, times the base, divided by 2, right? So that's 50 divided by 2. And so my area is 25. And reminder is that all you just found was the area of this triangle here. And now you can see what's nice about this trick is you have 3 more triangles to go. And in total you have 4. So the 4 triangles that you drew from the middle to the vertices are the same number as the sides of your shape. So what I can do is I can actually take this area and just multiply it by 4. And that'll give me 100. And that is the total area, I guess, of that square or this regular polygon, right? And so that just gave me the entire area right here. And you can follow this process every time. So I want to take a look at another example really quick to kind of practice this one more time. So we can look at, these problems here, for example. Take this right here. How many sides does this have? 1, 2, 3, 4, 5, 6, 7. Cool. So we have a heptagon here. And the first thing, right, I'm being asked to find the area of the entire polygon. And so the first thing I want to do is notice the things I am given, right? So if I'm given a side here, the value of a side, that would be such as saying the base of any of these, right? Regular polygons all have equal sides. So 7.8 is actually all around. Maybe I even want to rewrite it right down here so it's close to this. And so I'm given an apothem, right, or that mini triangle height of 8.1. And if you want to, I think it's always nice to draw out your mini triangles. And remember, once again, this has to go from the center to the vertices. So you shouldn't be drawing them into the mid segments of the sides at all. From center to vertices only. And so I'll draw that. Let's connect this, connect that. It's kind of covering my 8.1, but that's okay. All right, cool. And it's nice to have the visual, but remember that the same amount of sides that you do have on the regular polygon is actually how many triangles you have. So like a heptagon, we know it's 7 sides. So 7 sides is going to equal 7 mini triangles. And then now I can go with this, right? I can take my apothem or my height and my base, and I can solve the area of this first triangle right here. Divided by 2. Pull out my calculator and do that really quick. 7.8 times 8.1 divided by 2. That should give us, I'm going to round that to about 31.59. So I'll do it in the hundreds place for now. And then remember, this is just the value of the mini triangle. And I still have 7 mini triangles total. So now I can take this value and I'm going to multiply it by those 7 triangles. And then I'll probably just write my answer around here. So I'm going to take 31.59 times 7, and I'll round this also to the hundredths, and my total area of this entire heptagon is going to be 221.13. All right, so I hope that's helpful. We'll do one more example just to kind of make sure we got it down. Let's use a different type of regular polygon. Maybe we'll use this one right here. Cool. So let's go ahead and count the sides. 1, 2, 3, 4, 5, 6. So that is a hexagon. And so 6 sides equals 6 mini triangles. I have my apothem, that is 12, aka that mini triangle height, and I have a base of 13.9. That's 13.9 all around, so I'm just gonna go ahead and write it here. It's more convenient that way. Next step I'm gonna do is I'm going to draw my mini triangles by connecting the center to the vertices one more time. All right, so let's go ahead and find this area, and then we're going to multiply it by 6 mini triangles. So I got my apothem of 12 times the side length or the base, 13.9. I'm gonna divide that all by 2. I'll do that on my calculator. 12 times 13.9 divided by 2. I'll round out to the 10th place. So it looks like one mini triangle is worth 83.4. Last step to find the total area of this hexagon is to take that value of the mini triangle and multiply it by how many mini triangles I have, which is 6 in this case. And so our total, right, total area of this hexagon is 500.4. All right, hope that was helpful.